So, hello, every one of the participants. Today, we are having another session of the robotics session. And we are continuing our fruitful discussions in the AgriFood Forum 2021. And today, what we are talking about, that's working side by side with AgriFood robots, opportunities and challenges. And today we're going to have some presentations and we're going to be talking with the experts and representatives of big European consortiums working with the robots in agri-food sector. So let's not wait and let's start from the Dr. Rico Motzkel. I hope I'm pronouncing your last name right. He's Associate Professor of Cognitive Robotics and Intelligent Systems at Maastricht University. And today, Dr. Rico is going to be presenting CoRoSect project. Please, the floor is yours.
Thank you very much. And also, many thanks actually for the opportunity of presenting today. So I would like to take this opportunity to present our joint project, CoRoSect. CoRoSect stands for Cognitive Robotic Systems for Digitalized and Networked Automated Insect Farms. CoRoSect targets one of the key challenges actually that mankind is facing at the moment, and this is generating enough environmentally friendly food and exploring actually the required robotic and other technologies in the areas of artificial intelligence and data science to support healthy food production from insects. Overall, the project makes major contributions to a variety of different fields. One of them, of course, is the development of innovative robotic components and the necessary artificial intelligence in order to drive these robots. Here on the slide, you see like an overview of different technologies that are being developed within CoRoSect. There is an innovative concept of a so-called dynamic cell, where different robots work together. But you also see like here human workers. So there's an overall concept actually of a close human-robot collaboration where necessary, and strong automation actually where possible. Major concern in CoRoSect indeed is to have a healthy collaboration between human workers and robots, also in close proximity within the insect farms. And then in addition, you see also additional parts here. So we have like additional robots here that are used for transferring, in our case, these are crates of insects and other material that is required for the process of taking care of insects, for the insect rearing process. For this, we have a partner working with automated guided vehicles, AGVs. And you see also the close integration actually with the different stages that are required in order to take good care of the insects. Insects develop during different stages of their life cycle, requiring different conditions, and these are provided also by the insect farms. All of this is of course already like pushing quite a bit the boundaries of technological developments. But by itself, the components are even more useful, of course, when they are well integrated. And also here, CoRoSect follows a state-of-the-art concept of integrating workers and multiple robots together into an overall ecosystem that is then being centrally controlled by a manufacturing execution system. So in the end, workers actually inside these factories are really put into control of the different robotic components to receive the necessary information. And there's also partners actually involved with deep knowledge about insect rearing that are developing decision support systems, helping a good rearing process for these insects. Yeah, to summarize, overall the impact of CoRoSect, the goal of CoRoSect is to make a vital contribution to securing sustainable, environmentally friendly food production for humans and animals with insects at a large scale and in an automated way. With this, CoRoSect also makes impact and adds basically to reducing the risk of international conflicts by helping both the environment, protecting the environment, but also by protecting and increasing the quality of food sources available actually for people worldwide. The particular interesting part of producing food from insects is that greenhouse gas emissions and organic waste actually can be massively reduced. Insects are even able to be fed actually from some organic waste, so you can generate cyclic processes that are also taking care of organic waste while actually food sources are being produced. Land and water resources can be used more efficiently. And last but not least, of course, CoRoSect makes a huge impact by advancing the state of the art in robotics, artificial intelligence, the digitalization for industry and agriculture, and thereby also improving working conditions of workers and boosting the competitiveness of the EU in robotics and artificial intelligence. Thanks a lot.
Thank you a lot. Thank you for the short, brief introduction of the CoRoSect project. And let's continue further. Now I would like to give the floor to Daniel Calvo-Alonso. He's the head of the Artificial Intelligence, Data and Robotics Unit at ATOS Research and Innovation. And today, Daniel is going to be presenting the project FlexiGrowBots. Please, Daniel.
Okay, thanks so much. I will share my screen in order to show you the slides I have prepared about the project. So, okay, so first of all, thank you so much for the invitation to have the opportunity to talk in this great panel and to present what we are doing in FlexiGrowBots project. So FlexiGrowBots is focused on the development of flexible robots for intelligent automation of precision agriculture operations. It's an H2020 project that is being coordinated by ATOS. And as you know, during the last years, and thanks to the introduction of new digital technologies like IoT, big data, or artificial intelligence, the traditional procedures and tools used in agriculture are being radically transformed. IoT sensors are deployed in the crops in order to collect real-time information and observations from the soils, from the environment, and this information is then stored, processed, and used to make more intelligent decisions, discovering patterns, generating forecasts. And as part of this trend, drones and robots are starting to be used as an additional and powerful way to obtain high quality information from the crops and to execute also actions including fertilizers spreading or even harvesting. Nevertheless, in most of the cases, current agro-robotic systems are designed to automate just very specific tasks, being highly specialized and working in isolation. In many cases, with respect to the rest of the systems deployed in the crops. Moreover, the usage raises some concerns, as also Rico has introduced before for CoRoSect project, with respect to the potential safety risks for the human operators working in this case in the fields, or even potential damages that they could cause in the infrastructures due to their weight and big dimensions. We must take also into account that we need to have a specialized training for the management and operations of the robots, as is the case of drones that must be managed by pilots with a license. And all these aspects are leading to low return of investment and high risk for the farmers, which prevent the definite adoption of these technologies in larger scale in our fields. If we compare the issues of using large individual robots against fleets of smaller ones, we can see that some of these risks could be really mitigated. The usage of fleets of smaller robots imply less risks in terms of safety because they cannot cause the same damage, obviously. Also, if one of them they fail, uh, we can handle the situation by replanning the mission with the rest of the working units instead of just stopping the normal activities of our farms, which suppose important economic losses. And they are also more respectful with the field and the environment. Having appropriate tools, they can be managed and controlled just with a single operator. So FlexiRobot's goal is to make multi-robot systems cost-effective by employing multi-heterogeneous versatile robots through adaptive mission control mechanisms and enabling an agricultural data economy. The project aimed to build new systems composed of multiple heterogeneous robots that are able to collaborate to accomplish these complex missions, and they will be integrated within the rest of the systems in the fields, including also the possibility to collect information from the IoT sensors and from other already used platforms, and to exploit this data using artificial intelligence. To make this possible, the project has a consortium involving 16 partners from 8 European countries, covering a wide range of multidisciplinary and complementary competencies, as you can see in the slide. So in FlexiRobots project, we are going to define a reference architecture and to implement the enablers to build mission control of heterogeneous multi-robot systems, which will collaborate to accomplish complex missions for precision agriculture, integrating planning and supervising functionalities. We aim also to leverage the work that is being done in initiatives like international data spaces to break the silos between different platforms and opening a new door for new business models for the farmers. AI powered models will be embedded in the robots for perception, navigation, and decision making, but they will be also used by the farmers as a service or being integrated into the already existing solutions for decision support. And the project will also consider storing, accessing, and managing geospatial information. We are going to take into account the requirements proposed by the high-level expert group of artificial intelligence for trustworthy AI, providing also guidelines about their specific application in the agriculture domain. And the project includes 3 real-world large-scale pilots, as we will see in the next slides. So a common platform is going to be developed, considering several layers. First, interoperability through the usage of standards like ISOBUS or the Open Geospatial Consortium. Then we will have the core services with the AI platform and common services and functionalities, and the mission control center. And finally, the applications that will be built on top of the platform. About pilots, we have one in Spain that is focused on grapevines, and where we are going to use AI and robotic systems in order to early detect pests, to apply efficiently treatments, and also to transport the grapes, combining persons and robots. A second pilot will take place in Finland, in the north of Helsinki, focus on rapeseeds. And in this case, an additional challenge is the weather conditions. And again, we are talking about pest control, rumex plants, weeding, and silage harvesting. And the third pilot will be hosted between Serbia and Lithuania. And here, what we aim is to demonstrate the utility, adaptability, and scalability of the proposed solution, working in a similar crop, but in 2 different countries in parallel. So the final goal is that the project demonstrates the potential for robotic systems at the scale in the agriculture sector, operating over extended periods of time, contributing to reduce the current technical and commercial risks, and also supporting the role of digital innovation hubs in the transfer of technology. So that's all from my side. Thanks so much.
Thank you very much. And let's continue to our next speaker. And I'm introducing to you Annalie Rose, project manager at Civita Estonia. And today, Annalie is going to be presenting us the project Robotics for EU. Please, Annalie, the floor is yours. Annalie, we cannot hear you.
Thank you very much for introducing me, and thank you also to the colleagues for this impressive presentations of use cases which you are working on. I am going to introduce you the Robotics for EU project, which is a coordination and support action, and let's take a look at what are our goals and aims and how we work together with other projects, for example, with those who were presented here just a few minutes ago. So what are we aiming for? As coordination and support action, we are focusing on 4 different robotics areas, agri-food being one of them. And what is our main aim? Our main aim is to make sure that robots are in the future in Europe adopted more and more. We all know that there are definitely economic benefits which robotics will bring to our societies and lives. However, we also see that there are several challenges which arise if we are talking about more widespread adoption of robots. So, and this is why we would like to provide some support to our societies, that the barriers which might be there are reduced. And what does it mean? Obviously, seen from the technological perspective, the development of robotics technologies and AI-powered robots is really rapid, and we see a lot of potential here. However, we also see that there are some concerns which are maybe not related directly to the technological development, but on the impact which these technologies might have to the society. So this is why we think, and we are appointed basically by the European Commission to advocate for the non-technological aspects of robots, which are ethical, legal, socio-economic, privacy, cybersecurity, and also safety aspects. So, and how to address these issues? For us, it means that definitely all the stakeholders have to be engaged. It means that we would like to build a bridge between the industry, researchers, citizens, and policymakers. And we have agreed among our consortium that we use a term responsible robotics if we speak about those non-technological aspects. So if we consider the societal aspects and the impact which robots might have, then we think that this is a new term that we could use. So how do we achieve this everything, what I explained? As first, definitely, we wanted to know that what are the opinions of people and the stakeholders around us. And this is why we carried on a survey among the stakeholders, and we specifically also asked the citizens, also those who have never interacted with robots before, that what is the perception they have, or what do they imagine if they hear something about the robots and the benefits what robots can bring them as citizens or as professional users of robots. And we organize, of course, a lot of workshops also in the area of agri-food to raise awareness on these topics. And importantly, we would like to bring together companies and end users of robots to brainstorm together that how we could develop technologies which are with, let's say, positive societal impact. And this is why our consortium is also developing a societal readiness model and maturity assessment model, because if we speak about non-technological aspects of robots, then how can we know that we have complied with everything that would be needed? And we see that, of course, depending on the area we are operating, then either ethical values, socioeconomic needs, data issues, but also, of course, legal concerns and education and management issues should be addressed. So we are working on the maturity assessment model, and we would like to do it definitely together with all the stakeholders so that there would be some use out of this model for the developers of robots and of course also to the citizens and professional users of robots. So this is why we had a survey with more than 1,200 responses, and 21% of the responses came from the agri-food sector. So we are really proud that also the sector was very strongly represented. And so what did we find out? We found out that actually, of course, fear of technological unemployment is the biggest. It doesn't matter whether we ask the robotics community or also the policymakers, they all agree that this is a very common fear. Of course, maybe this is something that is not true, but this is how people feel that they are a bit afraid of this aspect. And what was really impressive was that policymakers considered, actually 53% of the policymakers thought that agri-food is this sector where these socioeconomic issues are the most pressing ones. And 42% of all people who responded to our survey mentioned that specifically education and engagement is important in agri-food area if we talk about robotics. So we saw also here in the introduction of the previous project that definitely training and information on how these robots should be used is very important. And of course, also safety was highlighted strongly by the people responding to the survey. So what is our aim and how we would like to make the impact is that at the end of this project, we hope that we have raised awareness about positive impacts of robots, as we know now that what are the concerns of the community. And we would like to make people also more aware that which are the solutions out there, because this was one of the concerns which was highlighted, that people are not aware on the different robotic solutions which they could benefit of. And as a result of our project, we hope that the professional users and citizens around Europe, they know more about robots, also in the agri-food sector, and they have less fears and more positive attitude about how robots can really make a positive change and difference, and how they don't take away the jobs, but rather replace, let's say, the dangerous or repetitive tasks, and people can instead of that focus on some other tasks where they could really contribute more in more meaningful ways. So thank you very much. I'm looking forward to our discussion.
Thank you so much, Anneli. Okay, and right away, I would like to continue. And my first question, just to continue on what you just have said. So in your opinion, in which areas or sectors can robotics be applied with the most efficiency or most success? As you said, you are spreading the importance of the robotics in different sectors. And based on the survey, what you have recently done, it looks that agri-food sector is the most interested in robotics, or maybe just the survey shows so. So please share your opinion.
Thank you very much for the question. So indeed, we are focusing on 4 different areas, which are quite different also. So agri-food is definitely one of the areas where I see that we also have quite a lot of European projects. So when we made a survey and collected some good practices, then we saw that that luckily, really, there are projects out there which are focusing a lot on the agri-food robots. And maybe this is one of the reasons why agri-food was highlighted also in this survey specifically. But I think that across those 4 areas, so healthcare, inspection and maintenance, agri-food and Asia production, I think there are everywhere opportunities where we can make use of the robots more in the future, but just sometimes I'm actually convinced that people, they don't know which kind of solutions are out there. And if you talk about the agri-food robots, then actually, according to the responses, then it was really considered important that the solutions that are created, that they prevent harm to animals, for example, and especially environmental and also energy saving targets were highlighted, so that the citizens and also robotics community, they saw a clear benefits which agricultural robots can bring. And of course, that it could increase safety and security at the workplace as well. So I think that this is the area also where the colleagues are working. So, so I think that all the sectors have their own potential.
Okay, I'm gonna continue with our all guests. And Rico, you are Associate Professor of Cognitive Robotics and Intelligent Systems at Maastricht University. So I'm sure you face different applications of robotics in different sectors. So what would be your opinion? Is agri-food could be a state art where the robotics is applied, or maybe not?
Yeah, many thanks for your question. Yeah, indeed, we see also from the university and from the many collaborations that we have with robotics companies and end users actually, that there's quite some push forward in robotics and its application actually in many different fields. There is, besides the agri-food sector, of course, also the entire sector of like manufacturing industries and the logistics sectors actually, who benefit strongly and who are traditionally actually very strong actually in robotics. What I see definitely also is, and that's something that I find very interesting and very meaningful, is that this push that originally started actually in the manufacturing industry now makes also its way into the agri-food sector. And I fully share the opinion of Anneli, and I say yes, the agri-food sector is actually going to be like one of the next big steps where robotization actually will have a major impact. And I think it's not just like a matter of like that we do their robotization for the sake of like trying out robots or running robots. It's more also there's like an incredible need from industries, from the agri-food industries actually, that more robots actually are being deployed and better robots are being built for these challenging conditions in the agri-food sector.
Thank you so much, Rico. And I'm gonna go to Daniel. And well, robotics and artificial intelligence, it seems it goes together. So in your opinion, what would be the key challenges that artificial intelligence and robotics could help solve us?
Yeah, okay, thanks so much for your question. I think that Anneli already describe some of the challenges that we are facing right now in the agriculture domain. Not only in the agriculture domain, but okay, mainly here because it's the topic we are targeting today. You know that there are several tasks that are very physically intensive. That the labor conditions of the workers in the farms at this moment probably are not the better in some countries or in some fields. So for sure, the usage of this kind of AI and robotics technologies could help to improve these conditions, and as Anneli already said, to move the human workers to a more high added value tasks. Also, I think that in general we are addressing in many European countries the problem that young people is leaving rural areas because they are interested in other kind of activities. And indeed, if we achieve to improve the conditions of our fields, of our crops, of our farms with this kind of AI and robotics technologies, probably we will achieve that younger people stay and that they work again in this sector, and in this way we can reinforce a bit the activity of our rural areas in Europe. So I think that AI and robotics could really help in these two aspects.
Thank you, Daniel, very much. And I would like to continue actually on the topic that you just mentioned. Everyone is talking about the population in the whole Europe. We are talking about missing villages already, youth is moving out, and etc. So does really robotics, disruptive technologies can help us to bring back people to rural areas? And if yes, what should be done? How it should be done? Anneli, please.
I think it's an extremely important topic. So because if we talk about societal impact, we also are talking at the same time about the societal challenges and problems. So, and this is the major impact which I think technologies can bring, that if we have societal challenges and we can develop technologies which offer solutions to those challenges and can really make a difference, then I'm convinced that we can achieve something big. So how this could be done, I think this is $1 million question probably, but one of those societal problems which we have are indeed that people are leaving countrysides. I think across Europe that there is urbanization, also the population is aging. So, and what is the image of the agri-food sector is probably currently in many countries that it's a very, let's say, hard work. you need to use a lot of physical power, and clearly there is a shortage of labor in several European countries. So I think that if there is a technological advancement which really also enables to, let's say, improve the image of this area, that it's not anymore really hard physical work, but that there are intelligent machines, there is really intelligent technology that can help you, and it will change the way how we actually work in the agri-food sector, then I believe that if there are from the governments also some supportive measures how to keep the life in rural areas alive, I think that this could make a difference, so that we can really boost the problem that we can solve the problem which we have with shortage of labor force, because we see also other problems like if we talk about aging population, at the same time, we also talk about limited resources and about food security. So definitely, I think that addressing the limited workforce issue with new emerging technologies is very, very crucial. So I hope that this will help also the governments to make respective policies and changes so that all these important challenges can be addressed properly.
Thank but when we talk that youth will be attracted to the rural areas, but we have older citizens already living and working there, can we help them with their reskilling or upskilling? Is it possible? Or maybe robotics is a very hard technology and very hard to understand. How can we improve access to robotic technologies to end users? Please, Rico, what is your opinion on that?
Yeah, you're raising also like here, like a very important question. Yeah, I fully agree, of course, that we need the robotic technology in order to support human labor, especially in those areas where we simply don't find enough human workers anymore. But you're also right, like there has to be like additional work actually in order to make these technologies then also accessible, both to maybe like older generations actually, which like maybe people like who have like less access and less experience with robots so far, but also to make this actually also attractive to younger generations. And I think a lot of exciting work is happening actually in Europe, and we have to facilitate this work more in order to make these robots simply more intelligent, so that the instruction to a robot becomes as easy and as straightforward as you would you instruct like a human worker on a particular job. For this, robots have to develop a lot more elaborated cognitive skills. We're really talking going away from like a standard harvesting machine that just gets automated in doing the harvesting towards like a cognitive system that understands instructions and that can also react in a flexible and in clever way, like a human worker actually would do. And there's a lot of work actually on this intersection between robotics and artificial intelligence in making agile robotic workers that are not just like good and provide like high quality in the operations that they're providing, but especially also when it comes to in the interaction between the robots and the humans. If you like, a very practical example also like from the CoRoSect project, we are indeed working on these robot cells where human workers will operate on a daily business together with these robots. And we cannot expect that skilled workers who are like working actually in insect farms will all have programming skills and will be able to communicate with a robot at the level that programmers typically would do or like roboticists would do. So we're working on things like also simple haptic interfaces. So guiding actually a robot, showing it what you want it to do in order the robot actually can understand what its next tasks actually are and which processes the robots actually should be executing. And I think these kind of interfaces can also be made ready to people who have like less experience with robots in such a way that they become valuable assets actually also in the urban environments.
Thank you very much, Rico. And it was an interesting point that you've said that robots, we are not talking about smart robots. We already are talking about intelligent robots. And if we talk about artificial intelligence robots, they are expected to enhance production, as we were talking, compensate the lack of manpower, reduce production costs, taking over unattractive jobs, for example, which are risky, as we heard, heavy or dirty, and reducing the burden of food production on the environment. But in spite of those promises that we are talking, however, artificial intelligence robots for agri-food also give rise to ethical questions and concerns, of course. So please, Daniel, share your opinion on the ethical part and the concern part about artificial intelligence robots.
Okay, thanks. Indeed, I think it's one of a very challenging question that we are addressing, I think, in the 3 projects right now and in the industry. So the first question that comes to my mind is clearly, okay, what is going to happen with all these workers that somehow will be replaced by the robots? Because it is true that we are saying, okay, that we need to move some of these people that now is taking care of the most difficult or the most the worst part of the tasks. We need to move them to more high quality and added value jobs. But it is true that some of these people may not find an easy upskilling plan. So we need to rethink what we are going to offer to them and how we are going to accommodate them in new positions. So clearly, this is one of the issues, of the ethical issues that we must address with respect to the usage of AI and robotic systems in general in the agri-food domain, but also in other use cases. Then there is also an important aspect about the liability. So what happens if one of these systems causes damage in the fields, in the crops, or in any other aspect of the environment where they are operating? Clearly, this kind of robots incorporate many different components. They incorporate software. They incorporate or interact with third-party applications, with third-party modules. So it is difficult to understand in which part of the system the problem has been originated, and also which company or which stakeholder is the responsible for the damages. And this is something that was already raised by the merging regulation that the European Commission is proposing. And also, as Rico said before, we must also address aspects about the interaction between the human workers and the robots, because we are not thinking about the scenarios where the robots or the intelligent machinery are going to operate in an isolated way by themselves. We are talking about collaborative use cases, and in this sense, we need to find appropriate mechanisms for these two types of actors to work together efficiently, safely, and also we need to find technical mechanisms so that humans can oversight the work of these robots. So, in my eyes, these are some of the ethical issues that we must address.
Thank you very much, Daniel. And I would like to continue on the other question. We talk about a lot of big objectives and with the Green Deal, what's coming up and what we need to achieve, what are our goals, and those goals are very big. So on one side, we say that robotics can help us to achieve environmental goals. From the other side, I hear that robots are not that environmentally friendly. So how is it? Please share your opinion. I'm going to start from Annalie.
Thank you for the question. So I think that here the colleagues developing robots on daily basis can also give their opinion that what about the sustainability of robots, or whether they as such are green. So I think that as in many cases we have to assess the pros and cons of this, so that whether the benefit which robots can bring is higher than the possible damage which they can bring, because obviously there are many issues which are not regulated currently. Also, Daniel mentioned that there is some legislation underway, and European Commission is also heavily working on standardization of robots. And in in regulating this area, which we maybe even don't know how this is going to develop, and which what is going to be out there, what we should regulate. So I think that we have to find a balance here, as very often in life, and we have to still see that how we can consider all those important points which are non-technological aspects of robots, including their environmental impact in the development process of robots. So this is why also at European scale, actually, interdisciplinary collaboration is very important, so that we could actually combine the knowledge of technological people and social scientists and to foresee all those points, and also do some life cycle assessment, for example, of technologies, to see that whether they are sustainable or not.
Thank you, Anneli. And Rico, what is your opinion on this? Or maybe if we can probably make sustainable robots or green robots, but then maybe the manufacturing price is very, very high and it's not effective anymore. What is your opinion?
Yeah, many thanks for the question. This is indeed a very challenging one, because on the one hand, we want to have highly reliable technology components that are operating also in challenging conditions. I'm thinking here especially again about the AgriFood sector, where things might get dirty, water, corrosion. So all of these things actually scream for technologies that are very sturdy and viable. At the same time, of course, there is like a strong interest in making sustainable technologies, so developing actually new types of robots from materials actually that are also environmentally friendly. I would say, like, at the moment, there's like still a lot of work actually that has to go into making new robotic components, and we really think about the robots themselves, making them actually environmentally friendly. But the main impact actually that we can make already actually in the agri-food sector is the type of circular engineering that we can actually deploy there. And my understanding there is that robots indeed can play like a very vital part in these processes. Not just as a replacement of human workers, but actually as a support actually, because you can start doing agri-food also in such conditions that are maybe like even less human friendly. I'm thinking about like not just operating actually under daylight on like open land, but like actually food and crop production actually in well-controlled factory environments. So there's quite some work actually in these directions, and we see that also particular for insect farms actually, where the main impact actually when it comes to environmental food really comes from the type of food production, less actually impact actually from the robotic components themselves. So I think the robots, in comparison to like the type of agri-food production, the robots actually have a very lower footprint actually on the environment than the agri-food production itself.
Thank you. And Daniel, as we can see, robots can make a good environmental impact and be green. But when we talk that robots are based on artificial intelligence, first question would be, what other disruptive technologies could be applied to the robotics? And do you think we can lower the actual end costs of the robotics? So is there going to be a time when when robots going to be quite affordable to everyone? Because right now, at least in agri-food sector, we know farmers say that it's a very expensive to apply robots to the farms. Please, Daniel.
Yes, I think that this has happened with every single technology in the last years. That at the beginning they are a bit expensive, but with the time they become more affordable. I think that on one hand, for sure, we need to create more versatile robots that can cover more wider set of tasks within the operations within the crops, so that in this way the amount of investment that must be done can be actually better compensated with a more intense use. Also, if we are able to create robots that, as Rico said before, can be built with more friendly, environmental friendly, or even recycled materials, for sure this will also help to reduce the costs. There is also some work that can be done in the area of artificial intelligence. So indeed, this is connected to the previous point about the um, sustainability of the robots. Why? Because in order to train very complex deep learning models that at this time are quite common in many aspects, and even in the robotic systems, you need a lot of data, you need a lot of computing power, and this indeed requires a lot of energy. It is the part, let's say, where the AI is not so sustainable. So if we are able to develop new AI systems that are able to learn, to evolve dynamically in the fields, in unstructured environments, for sure this will give us more versatile robots, more sustainable robots, and it will contribute also to reduce somehow the costs of these systems. There is also another pillar where robots could increase uh, their economic costs, and it's about the maintenance and the need for specialized training in order to operate this kind of systems, or to maintain this kind of systems. So if we are able also to create robotics technologies that can be somehow uh, controlled by any operator, or by any person, for sure we will also reduce some of these costs, and they will be incorporated in much more environments and scenarios.
Thank you very much. And well, maybe based on your projects that you are implementing right now and your use cases, maybe you could provide the most efficient part, or maybe the most successful that you already see part, in which parts of the agri-food sector robotics could be applied the best. Daniel?
Yeah, in the case of FlexiRobots project, we are focused on the farmers, on the farmers, or on the agriculture part. We are trying to develop systems that are able to early detect pests and diseases in the field, to apply in an accurate way fertilizers, pesticides. Indeed, this is also connected to the improving the environmental sustainability of the crops themselves. Um, and this is where I think that, at least from the FlexiRobots perspective, we think that robotic systems can make a difference. Then, of course, there are much more applications in the journey from the farm to the fork, in logistics, in processing, or even in the last mile, in the retailer. But yeah, in our case, we are covering this first phase, let's say.
Thank you. Enrico, I know your project is about insect farming, but my question is, can it be applied in a wider spectrum in the other parts of the agriculture, your systems?
Yes, absolutely. So CoRoSect indeed focuses with its pilots and with its studies actually on the insect farming particularly, but has a much wider scope in terms of developments. And I'm thinking here about quite a few different aspects. So we have been splitting the system actually into multiple very useful components. It starts with the robots that are actually built and which are taking care of the logistical processes within the insect farms. These robots, of course, are widely applicable also to other agriculture, other agri-food applications. If you have like autonomous guided vehicles actually driving inside in insect farms, the same vehicles, of course, maybe with some modifications, could also be deployed and used actually somewhere else. Another type of robots that CoRoSect focuses on is, I call them in a nice way, the nursing robots. So these are the ones actually which have to be quite agile and very careful, because they're really doing the fine manipulation actually of the insects. So you can imagine, like, if you have like clever robots or like intelligent robots that are capable of detecting all kind of different situations and then react accordingly and manipulate actually in a very careful way. Again, the same robots, of course, could be deployed and used also for other plants or possibly also like other types of animals, because the skills that you're developing there are still very useful. And then last but not least, I think, and that's also something that I learned again from Daniel, these robots by themselves, of course, as individuals are, of course, very interesting, but they really show all their possibilities once you start integrating them into an ecosystem. And many of the European projects, including CoRoSect, of course, work not just on the individual level of the robot, but generating the complete framework around this. Really putting people in charge, actually helping them actually to keep track of the operations of all these robots, coordinating actually all the different robots, and providing decision support systems so that the processes within the insect farms, or maybe more generally like in agriculture, can be optimized, and knowledge can be shared actually between different experts in these agriculture processes. So all these technologies that are being developed are, of course, vitally applicable and are not just focused on one particular application.
Thank you so much, Rikon. We are almost out of time. So I would like to ask each of the participants very shortly, just to conclude. So what is the future of agri-food robotics in EU and beyond? Please, Annalie.
I would like to conclude with a message that I think there is great potential, as explained here by the colleagues, but we should use the slogan of European Commission if we develop the robots, that technology should be developed with and for society. So I believe that many of those challenges which were mentioned here can be tackled in case we work together with the end users of our products. So I just really encourage everyone to break those silos and work together with colleagues from other areas, work together with the users of your products, so that even if you invest a bit more at the beginning, it can actually really bring you benefits, and it can really shift the future of agri-food robots.
Thank you. Please, Rico.
Yeah, to summarize some of the developments actually that we really see pushing forward. First of all, of course, there is like a strong push for robotization in many domains, and especially also in the agri-food sector. And what we see there is that especially cognitive robots, so robots that really gain a better understanding of the environment and also of the plants that they take care of or the animals that they take care of, are really like the future. We are looking at robots that are no longer hidden somewhere in a factory where humans hardly get actually into contact with them. But we are talking really about robots that make it out into the field and then also closely collaborate with humans there. And major feedback or like conclusion also, of course, here is that I'm very happy that the EU actually is addressing many of the ethical concerns, and that also the European projects that we are taking care of typically have very strong partners actually from the ethical and legal side, because we have to integrate this well into society and work actually for the humans, not just for the technology.
Thank you, and please, Daniel.
To conclude, I think that I fully agreed with Anneli and with Rico. We need to develop new AI and robotic systems that are human-centric, that are developed together with end users and with the rest of the stakeholders that are involved in the agri-food sector. And we need to ensure that they are trustworthy, that they respect the principles and the values of the European Union, so that they can really make impact in the agri-food processes and use cases. Because for sure we are talking about, as Rico said before, environments that require close interaction between these robots and the human workers there. So I think that these are the main challenges that we need to address in the next years.
Thank you so much. And I would like to thank all the participants in this panelist. Thank you for presenting your fantastic projects. We are going to be looking at your results and the impact, and hoping for the more projects to come in the future. And I would like to end with the sentence that we need to change our thinking, our state of mind. The robots are not future anymore. They are already reality. So we need to understand that we're going to be working a lot with this technology now and in the future. So good luck, everyone, and thank you for the fruitful discussion.